Okay, recording.
Okay, I start.
Okay.
All right, I think the recording has started. Hi everyone, thanks for joining. So for our IoT assignment, we are supposed to analyze a use case from chapter 6, which focus on IPv6 technologies. We decided to use case 2 from the IoT 6 European research project, the safety alert and dynamic routing scenario. Basically, this use case shows how IPv6 supports intelligent and priority-based routing when a dangerous situation happens. Siwin, can you start by explaining the basic setup of the system?
Sure. The setup is actually quite simple. We have an IPv6 enable temperature sensor, which we'll call sensor S, installed somewhere inside a building. The sensor continuously sends temperature readings to a control and management system, or CMS, which operates as a cloud service in the IoT environment. The whole process starts when the sensor detects a temperature reading that is outside the safe operating range. Once that abnormal value is detected, it triggers the entire safety alert workflow.
So under normal conditions, the sensor just keeps the sending regular data, but once the temperature exceeds the threshold, the system reacts differently.
Treated as standard monitoring data. But when the temperature exceeds the predefined threshold, the system immediately treats it as a critical alert instead of routine telemetry.
This is where the CMS becomes really important. Once the CMS receives the abnormal temperature reading, it doesn't just store the data, it detects anomaly, marks the message as an alert, and assigns it a higher priority before forwarding it to the smart router. That priority tagging step is actually very important because it tells the rest of the system that this message requires urgent handling.
And that's where the smart router takes over. What makes it smart is that it doesn't process every message the same way. Instead, it checks the priority tag added by the CMS and decide where the message should be routed. And if it's a normal reading, it follows the standard routing path. But if it's marked as an alert, the router immediately redirects it to a higher priority destination. This decision-making capability is what makes the IoT architecture more intelligent rather than just acting like a normal data transmission system.
To explain the normal routing path first, when the temperature stays within a safe range, the smart router forwards the sensor data to the Building Energy Management Server, or BEMS. The BEMS mainly handles monitoring, logging, and analyzing the building's energy usage. So during normal operation, the sensor readings are simply used for energy management and reporting purpose.
But in this scenario, since the temperature becomes dangerously high, the smart router bypass the BMS completely and send the alert directly to the safety server, which is called SDS. The safety server is specifically designed to handle emergency situation. As soon as it receives the alert message, it immediately starts the safety response process without any delay.
After that, the first thing the safety server does is contact the global resource territory, or GRD, to identify the exact physical location of the temperature sensor. The GRD basically works like a central registry that store information about IoT device and their location. The safety server needs this information so that it can identify nearby alarm device and determine which people are close enough to respond the emergency.
Once the safety server gets the sensor location, it's proceed to activate the nearest alarm device. There are actually two possible situations here. If the server already had a store list of nearby alarm devices, it simply compare their location with the sensor location and activates the closest alarm using an IPv6 command. However, if there is no existing lead available, the server sends a live query to the GRD to search for alarm-capable devices within a specific radius. For example, 15 meters from the incident location. Any suitable device found within that range will then be activated.
And besides activating alarms, the system also needs to notify the responsible personnel. The safety server may already have a store list of emergency contacts, such as fire wardens or building engineers. In that case, the CMS queries GRD again to retrieve the real-time location of those IP version 6 enabled mobile device. Once the system identifies the personnel closest to the incident, it sends them a direct alert notification. This ensures that the right people are informed immediately instead of sending alerts to everyone unnecessarily.
To conclude, I think this use case clearly demonstrates how flexible and powerful IP version 6 can be in IoT systems. If we look at the overall architecture, every communication involved from the sensor readings, SAMS detection, smart router decisions, safety server responses, alarm activation, and mobile notifications are operated using IP version 6. This shows how different types of IoT devices can communicate seamlessly using a single protocol. On top of that, if legacy devices are still being used, the IoT 6 gateway can be added to provide compatibility and protocol translation similar to what was shown in use case 1.
That was a really good explanation from everyone. I think we covered the entire process clearly, starting from the sensor detection all the way to the emergency response and the overall role of IPv6. Since we are using these discussions as preparation for the final report, let's do a quick recap of everyone assigned section. Xingyun, you can start first.
Okay, I'll be covering the baseline scenario and temperature sensor setup section. I will explain how the IP version 6 enabled sensor operates, how it continuously sends readings to the CMS, and how abnormal temperature values trigger the alert process.
For me, I will handle the CMS detection and alert tagging section. My focus will be on how the CMS identify abnormal readings, assign priority tags, and why that tagging mechanism is essential for dynamic routing.
So I'll be responsible for the smart router and dynamic routing logic section. I will explain how the smart router analyzes the priority tags and perform different routing decisions based on the message type.
I'll cover the normal routing path to BEM's section. I want to explain the standard non-alert data flow clearly, so the difference between normal routing and emergency routing becomes more obvious.
I will during the alert routing part and safety server activation section. I will explain how the smart router direct emergency message to the safety server and how the safety response workflow begins.
I am handling the global resources directory and location lookup parts. I will explain the role of GRD and how it's helped the system retrieve real-time location information for this device and users.
I will work on alarm device activation and vicinity search session. I explain both the pre-store devices approach and the live GRD query approach, including how the 15-meter search radius works.
And I will cover the human notification via mobile phones section. And I will explain how the system locates responsible personnel and sends targeted emergency notification to the nearest available person.
And I'll be writing the conclusion, which focuses on IP version 6 diversity, business value, and legacy integration. I'll summarize how IP version 6 connect all the devices together in a unified system and explain how IoT gateway support all the legacy devices.
Perfect. I think the division of sections is very clear now, and everything links nicely back to chapter 6. I will prepare the share Google document later tonight so everyone can start drafting their parts. Does anyone have anything else to add before I stop the recording? All right, then great job everyone. I will stop the recording now.